Topic 3, Day 7, Trigonometric Ratios using the unit circle. So up until this point, there are 3 trig ratios that you should be familiar with: sine, cosine, and tangent. There are actually 3 additional trig ratios that are just the reciprocals of the ones that you have already talked about. So for example, sine of theta equals our opposite over our hypotenuse. Cosecant, CSC, flips our fraction, is the reciprocal. So we're going to have our hypotenuse over our opposite. And then similarly, if we know that cosine is adjacent over hypotenuse, then our secant is just hypotenuse over adjacent. And then cotangent is, instead of opposite over adjacent, adjacent over opposite. Okay. One way that you can remember the reciprocals is that the tangents go together. They're reciprocals of each other. And then C goes with S and C goes with S. So sine and cosecant are reciprocals, and then cosine and secant are reciprocals. Okay, we went over this already when we talked about the unit circle, but since the hypotenuse on our unit circle is always 1, the coordinate points around our unit circle is always cosine, then sine. The x value of our coordinate plane is equal to the cosine at that angle, and the y is equal to the sine at that angle. And we can just go through a quick example. If we have our unit circle and I have my 30-degree angle here, right? At this coordinate point, I know that we have root 3 over 2 and 1/2, which makes my x value root 3 over 2, and my y value 1/2, and my hypotenuse is 1. If I can label my opposite side, my adjacent side, and my hypotenuse, then I know that sine of 30 is going to equal opposite over hypotenuse, 1/2 over 1, which reduces to 1/2, right? And that corresponds with our y value. Similarly, if we have cosine of 30, find that it's root 3 over 2 divided by 1, adjacent over hypotenuse, which again reduces to root 3 over 2, which corresponds to our x value. So again, we're able to use our unit circle to help us find the sine and cosine at those angle measurements. Now, angles of rotations are formed on the coordinate plane between the positive x-axis and the ray. So our initial is always going to be our positive x value. And from that point, all of our angles are either going to go up towards our quadrant 1 or down towards our quadrant 4. If it moves up in our counterclockwise direction, then we have a positive angle of rotation. In our positive angle of rotation, you can think of going from Q1 to our second quadrant, to our third quadrant, to our fourth quadrant. So it goes in order of our quadrants, and that gives us a positive angle of rotation. However, if we start from that initial or positive x value side and we go in a clockwise direction and we go first to our fourth quadrant and then move over to our third, second, or first, then we have a negative angle of rotation. Now, an angle of rotation can be described in infinitely many ways. They can just be described by positive or negative angles of rotation, or by making multiple full circles of rotations through the 360 degrees. So for example, if we have this angle of rotation, which I will kind of highlight in black, So this is the angle that we're looking at here, right? And from our positive x-axis, there are multiple ways that we can name this angle, right? So one way is just by saying 165 degrees, right? From 0, we go past 90, we haven't hit 180 yet, it's at 165 degrees. However, if we want to go in the negative direction, then we've gone in the negative direction a little bit past 180 degrees. So we have our negative 195 degrees, right? And both of those, positive or negative, gets us to that same angle. From there, we can add or subtract 360 infinitely number of times in order to get other ways to name this angle. So if I do 165 plus 360, we end up with 525. And 525 is if we had taken one full circle all the way around 360 and then kept going an additional 165. And that gets us to our 525 degrees, right? And from there, we can add another 360 degrees and another 360 degrees, right? And they would all be ways to name our angle. Okay, so our first teacher example asks us to find the exact value of sine of 7 pi 6. So right off the bat, I'm able to identify we are in radians. So I need to think about my unit circle in radians. And for this example, I have a unit circle printed below, and I can find my 7 pi 6 is just past pi a little bit, and it tells me my coordinate point is negative root 3 over 2 and negative 1/2. Since I'm looking for sine, I want my y value, which means my sine of 7 pi 6 equals negative 1/2. Okay, and if you want to double check on your calculator, you can do so by making sure first that your calculator is in radians, and you can click sine 7 pi over 6, and you'll get negative 0.5, which is equivalent to negative 1/2. Try your first student example, please. Now, we're asked to find the exact value of cosecant of negative pi fourths. So there's two things that are fundamentally different about this teacher example from the first one. One, we're using a trig ratio that is new to us, cosecant, which means we need to first identify what is it the reciprocal of. So cosecant of theta is equal to 1 over sine of theta. Okay, cosecant is also equal to hypotenuse over opposite. Okay, so we can think about it either way to get our final answer. We also need to be able to identify our negative pi fourths, right? So we know negative, we're going to be going in the negative direction this way, the equivalent amount of pi fourths, right? And that tells us that negative pi fourths is equivalent to 7 pi fourths. So, in other words, we're looking for what is a cosecant of 7 pi fourths. And here, we know that our sine and cosine is root 2 over 2 and negative root 2 over 2. So this one is our cosine value, this is our sine value. So we're going to use our sine value and then take the reciprocal of it, right? So you can kind of flip your fraction, or you can do like 1 over that value. So the reciprocal of sine is going to be negative 2 over the square root of 2. And again, we don't like having our square roots in the denominator, so we're going to multiply by the root 2 times root 2, rationalize our denominator, negative 2 square root of 2 over 2, and we end up with negative root 2. That tells us cosecant of negative pi fourths equals negative square root of 2. Okay, now if you find where the cosecant button on the calculator is, please let me know, because I actually don't know where it is. But one way that you can check your answer is by just taking the reciprocal. So set up your fraction 1 over, so alpha x, and then put 1 in the numerator, and then you can put sine, because again, we're taking the reciprocal of the sine value, which is what cosecant is equal to, and then type in negative pi fourths, and then you'll get that decimal. So then you can put negative square root of 2, and then double check that those values are equivalent. Try the second student example on your own. Now the last student example asks us to find the value of tangent of 13 pi fourths. And hopefully what you can identify is that 13 pi fourths is greater than 2 pi. So 13 pi fourths is greater than, so 2 pi, which is also 8 pi fourths, right? So since our unit circle only goes to 2 pi, we need to figure out what is the equivalent angle to 13 pi fourths between 0 and 2 pi. So I'm going to do 13 pi fourths, subtract 8 pi fourths, and I end up with 5 pi fourths. And now I can think about where is 5 pi fourths on my unit circle. It's going to be right about here. And then both of my x and y values are going to be negative. And since it's a 45-degree or pi fourths reference angle here, I'm going to have negative root 2 over 2 and negative root 2 over 2, right? So I need to do my kind of tangent. Thinking about tangent is opposite over adjacent, right? So here's my opposite, here is my adjacent, and I can just make a big fraction, right? So tangent of 5 pi fourths equals negative root 2 over 2 divided by negative root 2 over 2, which simplifies to 1. Anytime where the numerator and the denominator are equivalent, where they're the same, then they equal 1. So our final answer, tangent of 13 pi fourths equals 1. Go ahead and try student example number 3 on your own.